Thanks to Skillshare for supporting this episode of SciShow. Over the years, scientists have found evidence for a lot of weird prehistoric animals, but some of the strangest have been crocodiliforms. These animals belong to a group that's existed for millions of years, and that today includes modern crocodiles. We call these animals Crocs for short, since crocodiliforms, it's kind of a mouthful. Some of these things were super weird. Modern crocodiles might seem to all follow roughly the same body plan, but some of their prehistoric relatives look strangely like other animals. We're talking like duck croc, rat croc, pug croc, cat croc. These adaptations weren't totally random, though. Many of them are examples of convergent evolution. Basically, this is where traits are so useful that they show up again and again in animals that are not closely related. Like bats and birds are not closely related, but they did converge on flight by flapping bits of their bodies around, possibly as a way to get around quickly while avoiding predators. And crocs, too, converged on many traits that gave them an advantage depending on the environmental niche that they lived in. Which is how we ended up with these 5 very strange, but very lovely examples. Mourasuchus was a group of crocodiliforms that lived in South America during the Miocene, about 5 to 23 million years ago. During this time, the Amazon may have been dominated by a vast wetland, and a wide variety of crocs would have called it home. What made the Mourasuchus stand out, though, was their heads. Scientists have identified several species of these crocs, and each had an unusually long and broad skull. The skulls were topped with a snout that looked kind of like a duck's bill, and they were filled with lots of slender little teeth. As for why, well, it's been suggested that these things might have actually eaten more like baleen whales than like modern crocodiles. They may have used filter feeding to catch their meals, engulfing water and small aquatic prey, then straining out the water and swallowing what was left. As for why they evolved such an odd diet, scientists say this might have been an example of what's known as resource partitioning. There were a lot of crocs in South America at this time, and there's only ever a certain amount of food to go around in any given ecosystem. If all the crocodiliforms were out chasing the same food, they'd be under intense competition with each other. By specializing in only getting a certain type of food, Mourasuchus and other crocs might have been able to limit their competition and thus carve out niches for themselves. Some would have hunted fish, and others would have specialized in hard-shelled prey like crabs, while Mourasuchus filtered their food from the water. Granted, the filter feeding idea is a hypothesis and not everyone agrees on it, but since scientists have found at least one other crocodiliform that might have also been a filter feeder, it's probably not outlandish. During the Cretaceous, from 144 million years ago to 65 million years ago, North Africa was a rich ecosystem full of lakes and rivers and animals. It was also home to a wide array of crocodiliforms, just like South America was millions of years later. And some of them, like Kaprosuchus saharicus, took the need to diversify to terrifying extremes. Kaprosuchus, nicknamed the boar croc for its tusk-like teeth, might have looked kind of like a cross between a crocodile and a wolf or big cat like a leopard. It was 6 meters long, had forward-facing eyes like a predatory cat, and had big muscular jaws that came equipped with 3 sets of long, sharp teeth. Its nose might have also sported a keratin-reinforced shield that could be used like a battering ram. Basically, its entire snout was potentially built for high-impact hunting. And although we've only ever found its skull, the scientists who discovered it suggest that Kaprosuchus might have even held its legs beneath its body instead of splayed out like a modern croc. That would have made it more agile on land. The reason this thing shared so many features with land predators is that it may have actually hunted on land, maybe tackling big terrestrial prey like dinosaurs. These new features were biological responses to the challenges of this lifestyle. The forward-facing eyes, for example, might have evolved to help it judge distances more precisely or see through camouflage better. Modern crocodiles are ambush predators, so their eyes are on the top of their head to help them watch for prey as they float in the water. Different niches require different strategies. While Kaprosuchus might might have been the most intimidating crocodiliform to make the jump to land, at least partially, it was far from the only one. The same expedition that discovered it also found a bunch of other weird crocodiliforms, including the dog croc, which might have had a soft dog-like nose, and the rat croc, which was tiny and had buck teeth. The most striking land dweller, though, may have been Armadillosuchus arudi. Found in Brazil during the Cretaceous, it really lived up to its name. All modern crocs have armor in the form of osteoderms, which are small, bony deposits in the skin, but Armadillosuchus took this a step further. It grew a full set of rigid body armor separated into mobile bands like a modern armadillo. It also had big claws and robust shoulder bones, which suggest it might have actually been able to dig or burrow, again, kinda like an armadillo. The area it lived in at the time was a hot, semi-arid environment, so these big claws might have helped it dig up food or scavenge for dead animals. This could also have enabled Armadillosuchus to be an omnivore, which was a relatively open niche that mammals, which were somewhat rare at the time, had not yet filled up. As for why it evolved such strong armor, we can't say for sure, but well, it wasn't the only crocodiliform in the area. Fossils of Armadillosuchus have often been found near big predatory crocodiliforms known as Mourasuchus. So, like a modern armadillo, the extra armor could have helped it ward off predators that maybe it was somewhat closely related to. After all, just because you're a croc doesn't mean you're always at the top of the croc food chain. Of course, some crocodiliforms didn't take to land. Instead, they doubled down on hunting in the water. Pelagosaurus typus, for example, was an ocean-going crocodiliform that lived during the Jurassic about 180 million years ago. It lived in shallow, near-shore seas that covered what is today Western Europe. One of the things that really sticks out about Pelagosaurus is its snout. It is super long and thin, similar to modern gharials. And actually, this super skinny skull shape has cropped up a bunch of different times before in distantly related crocodiliform species. So scientists think this is another example of convergent evolution, this time as a special adaptation for catching fish. Having a slender snout limits how hard a creature can bite down on prey. So if you're trying to snag something big and tough, a skinny snout would be a bad idea. But the trade-off is that a skinny snout can move through the water much faster, letting you swipe your head back and forth much quicker. So if your diet is agile but relatively small and soft, like, say, a fish, that might be a worthwhile trade-off. And we know that Pelagosaurus hunted fish. One fossil was actually found with an early bony fish in its stomach. But though Pelagosaurus's adaptations may have been the result of taking to the ocean, there were crocodiliforms that took the body changes even further. Our last example of a weird croc is a group called the Metriorhynchids. These might have had the most extreme changes to their body plan and some of the clearest examples of convergent evolution. As the Metriorhynchids' ancestors adapted to life at sea, their limbs became paddle-shaped, like a manatee, while their tails grew shark-like flukes. They also lost the typical crocodilomorph's signature armor in favor of streamlined skin like a dolphin or seal. These adaptations would have helped them maneuver through the water. A streamlined body shape helped reduce drag, for instance. This would have made it easier and less energy-intensive for them to move around. They also developed glands that excrete salt like the ones that sea turtles have. Ingesting too much salt is harmful and even potentially fatal for most life. But if you live in the ocean, it can be hard to avoid that. So by developing a special gland to rid themselves of the excess, Metriorhynchids could eat salty sea life or swallow water without getting sick. All of these adaptations, of course, were in response to them going from the land into the ocean. And after examining the animal's hips, scientists have even suggested that they adapted to giving live birth, which would have let them avoid having to come out of the water to lay eggs. Metriorhynchids were very successful in their time with lots of different species and wide ranges. Fossils have been found from South America to Europe, from the Middle Jurassic all the way up to the early Cretaceous when they disappeared, possibly due to shifting sea levels. It's really striking to see how often we see convergent evolution occurring among the crocodiliforms, from adapting to life at sea to developing armadillo-like armor to protect yourself from other crocs. This lineage is diverse and surprising, full of oddities and offshoots parachutes, and whether adapting to new habitats, finding the right niche or food supply, or avoiding getting eaten, the crocodiliforms provide some amazing examples of how similar patterns emerge to combat similar problems. These animals are also just really cool to look at, or at least the artists' interpretations of them are, and if looking at these pictures is making you wish you were better at illustrating, well, there's a Skillshare class for that. It's about mastering the basics of Adobe Illustrator, and it's taught by an artist named Julian Burford. He won't teach you how to illustrate Crocs, but he will teach you all the basics you need to get started. Once you're done, you could also check out one of Skillshare's other classes, because they have over 25,000 of them, and with a premium membership, you can get unlimited access to them all. Skillshare is a great way to learn new skills as a creator, and it's also really affordable at less than $10 a month. The SciShow team actually uses it all the time. You can join us and more than 7 million other creators by checking out the link in the description. The first 500 people to use that link will get a 2-month trial for free.